Random House Audio presents The Genome War, How Craig Venter Tried to Capture the Code of Life and Save the World, by James Shreeve. Read for you by Erik Singer. On May 8, 1998, Nicholas Wade, a veteran science writer for the New York Times, entered the lobby of the St. Regis Hotel. The day before, he had received a call from a public relations representative of the Perkin-Elmer Corporation offering him an exclusive story on an exciting development. Wade was leery. Public relations people often overestimate the media interest in their company's announcements, but the PR rep mentioned that Craig Venter was a player in the new enterprise. Wade agreed to meet with Perkin-Elmer's executives over breakfast. In the Perkin-Elmer suite on the 14th floor, he was introduced to CEO Tony White and two other company executives. One was Peter Barrett. The other was Michael Hunkapiller, head of Perkin-Elmer's Applied Biosystems division near San Francisco. Largely unknown outside the biotech world, Hunkapiller was a legend within it. In the late 1980s, he had co-invented a machine that could automatically sequence DNA, that is, read out the order of a short stretch of chemical letters in the genetic code. Since then, his technical genius and business acumen had made him the linchpin of an ongoing effort to develop better, faster instruments for sequencing DNA and speeding up other biotechnical processes. A lavish breakfast buffet had been set up on a sideboard. Craig Venter was not in the room, but his voice greeted Wade from a speakerphone sitting on a coffee table. "Hey, Nick," he said in a disarmingly mild tone. "Thanks for coming in so early. There's something we wanted you to be the first to know. Are you sitting down?" Wade took a chair and opened his notebook. First Venter talked, then Hunkapiller, then Venter again at greater length. Tony White offered an occasional comment in a broad southern drawl. No one touched the breakfast. Wade sat erect, furiously taking notes. He left an hour and a half later, certain that he had the lead story for the coveted front page of the Sunday edition of the Times. Genome is not a pretty word. Even when you say it in a normal tone of voice, you sound like you're mumbling. It has so recently come into common usage that until 1997, almost a decade after the Human Genome Project began, Microsoft Word's spell checker corrected it to the Human Genome Project. 2 copies of your genome, one contributed by each of your parents, are spooled on the 23 chromosomes inside the nucleus of every one of your cells, except for red blood. The spool is fantastically compact. Each copy is a double-stranded molecule of DNA only 79 billionths of an inch wide, but which, stretched out, would run almost 6 feet in length. Upon this thread, imagine a clothesline running the length of the United States, then back again, lie the chemical instructions that have informed the development of your body and brain from the moment you were conceived. The individual units of instruction are called genes. They are composed of strings of the 4 chemical bases of DNA: adenine, thymine, guanine, and cytosine, abbreviated A, T, G, and C by scientists. The cell's machinery forms the letters into a series of 3-letter words that combined give the recipe for the construction of a specific protein: an enzyme that helps you digest a tuna sandwich, an antibody molecule marshaled to fight off an infection, a receptor protein in your brain that helps you hear and understand this paragraph. The whole human genome contains about 3 billion letters and is often compared to the text of a book. Instead of thinking of the genome as a book, imagine it as a piano keyboard. Each piano key represents one gene. If you press down on a key, you hear a single note, the protein that the gene expresses. But with a piano keyboard, you can do much more than play lots of individual notes. You can combine the notes to make music. Just so, our various cell types play upon the long, thin keyboard of the genome. They combine notes, playing some genes together as chords, tripping several together in a phrase, gathering bundles of notes to create the complex and wonderful effects that find expression in our biological being. Beautiful music, all of it. But think what can happen if an important key on the piano sticks or sounds the wrong note when struck. In the United States, 1 child out of every 4,000 is born with cystic fibrosis, which is caused by a defective gene on chromosome 7. Children with this particular stuck key have abnormally thick mucus in their lungs. Most will die before their 30th birthday. Huntington's disease occurs because a gene near the top of chromosome 4 contains a series of repeated stutters on the letters CAG, playing them over and over like a scratched recording. The patient goes mad and inevitably dies. Single gene alterations account for some 3,000 to 4,000 other inherited diseases. Hard as these defects are to track down, they are by far the easiest targets for gene hunters. Most diseases, including such common killers as cancer and heart disease, stem from disruptions in the interaction among several genes and between genes and the environment. To find their causes, you have to first know what all the keys on the piano are. You have to know the whole genome. After leaving the St. Regis Hotel, Nicholas Wade tried to reach Francis Collins, the head of the government's Genome Project, whose official title was Director of the National Human Genome Research Institute, or NHGRI, one of the National Institutes of Health. Collins, more or less against his will, was on a plane headed to Dulles Airport, where he would catch a flight to Los Angeles. He had originally been scheduled to fly straight to L.A., but the evening before, he had gotten a phone call. The mere sound of Venter's voice on the line gave Collins a shiver of apprehension. "Francis, I think you need to know about something we're about to announce," Venter said. "We have to meet with you right away." "Who is we?" Collins asked. "I can't tell you that," Venter replied. "I don't mean to sound coy. I'm just not authorized to talk about it yet." The two men had known each other for over a decade. When they were first introduced, Craig Venter was an obscure 40-year-old researcher in the National Institute for Neurological Diseases and Stroke, also part of the NIH. Francis Collins was several years younger, but well on his way to becoming perhaps the most famous gene hunter in the world. Soon he would claim a share of the credit for the discovery of 5 disease-related genes, including 2 of the most important ones yet found, those responsible for cystic fibrosis and Huntington's disease. In 1994, at the age of 43, Collins was enticed to leave his large, heavily funded laboratory at the University of Michigan and come to Bethesda, Maryland, to assume leadership of the Human Genome Project, then in its 4th year. The job change meant a cut in pay and much less time for research, but Collins would be in charge of a $200 million annual budget earmarked for an historic enterprise. The decision was a no-brainer. "There is only one human genome program," Collins said when he took the post. "The chance to stand at the helm of that project and put my own personal stamp on it is more than I could imagine." Now, 4 years later, Collins still saw himself as the captain of a great ship moving steadily toward its destination. In Collins' words, and under his leadership, the Human Genome Project had taken on an almost messianic quality, a noble, historic undertaking whose importance was bigger than splitting the atom and dwarfed going to the moon. He referred to the genome in his public lectures as the Book of Life. A part of such rhetoric was expediency, of course. If your program is dependent on taxpayers' money, you must define your mission in the loftiest possible terms. But Collins believed devoutly in his own propaganda. He was a medical geneticist by training, and he was convinced that in time knowing the code would relieve untold suffering. He was also a man of faith, a born-again Christian. For Francis Collins, the human genetic code was part of the unimaginably immense knowledge of the Creator. Uncovering its sequence would provide a tiny, magnificent glimpse into the nature of God's mind. There were people within the genome community, Craig Venter among them, who had begun to rail at the slow pace of the Human Genome Project, but in Collins' view, such an obligation should not be rushed. Reluctantly, Collins agreed to change his Los Angeles flight to accommodate a meeting in a private room of the Dulles Red Carpet Club, the business-class lounge of United Airlines. He called some of his staff.
Sample complete. Ready to continue?